So in this video, I'll be demonstrating my distributed Halloween simulation. So first off, we have 3 clients in my server running, and the first thing we're going to test out is the non-atomic mode. So we're going to set atomic to false. False. That's the wrong client. So now that they're all set to false, we have a breakpoint in my reader thread of the server, basically stopping it before broadcast so that we can see it working in non-atomic mode. So we're just going to do a simple command. So as you can see, it moved one of our clients, and if we look at the debug console, it has suspended at the breakpoint at 36. So what's happened is it's executed the local command, sent that up to the server, and the server has got it, and it's about to broadcast it back to the other two. So when we press F8 and we run the rest of the program, we should see the other 2 simulations move. Okay, so now we're going to go through the atomic broadcast mode. So we got to set everything back to atomic mode. So now what we should expect to see is when we type in a command, it's not going to be locally processed by the client. It's going to be sent up to the server and then rebroadcast back to the other clients and the original client. So this time, the difference we should see is that we'll type the command, it'll get to our breakpoint, but no animation will have run on any of the clients. Once we go through the breakpoint and let the program execute, we should see it run on all 3 simultaneously. So we're going to do this with the last one we did. We're going to just give back the cupcake that we took. So we just ran the command, and as you saw, it hasn't run on the clients. Go back to our debug tab, we'll see that we're once again suspended at the breakpoint. If we run through it, all 3 of them give it. So that is the atomic mode. So now we're going to go through the trace of the console for one of our commands on the client. We're going to be looking at the command when we were in non-atomic mode and we decided to take a cupcake. So since this was in non-atomic mode, the command is processed. Then the socket channel is notified of this property change, and it creates a write command object that is enqueued, and then the main thread wakes up the selector thread. So now that the selector thread is unblocked, it needs to change its interest op to 4, which means that it can write to the socket channel. Select is called, the write request is dequeued, it's written, and then it changes its interest op back to 0, says that the write buffer is empty, and then calls select again, which it blocks on, and it was blocking until we set the atomic state back to true. So now we're going to discuss the difference in the stack trace between non-atomic and atomic mode in our client. So like we talked about in the last part about non-atomic mode, when I ran this command to take a cupcake, it ran the command locally and then sent it up to the server, which the last thing we talked about was when the write buffer is empty, it was done, so it just calls select and blocked until something would happen. So then we came back and we set the client to true, or the atomic value to true, so now it's in atomic mode, and we ran the command to give the cupcake back. So the main part, or the beginning part, is the same, where it writes to the socket channel and sends that to the server. But where the difference is what happens after the write buffer is empty. So it calls select again and it blocks. But this time the select thread is going to unblock itself when it gets the message sent back from the server. So now it's going to go through the process of reading it through the socket channel, which are these commands here, and then eventually send it to the read thread for it to be processed. Okay, so now we're going to run the experimental input command, and I went ahead and set the traces to false so we don't have to deal with that problem, and set everything to true before the video to save time, so let's go ahead and run it. So it looks like the top 2 have gotten a little out of sync, where they probably just missed an input or 2, but the bottom one now seems to be moving faster. And so now it's finished. So now we're going to run the experiment with atomic false. So here we go. As you saw in that, the bottom one finished earlier, which was the one that was running the commands locally, which makes sense. Okay, so now we're going to do local processing only. So you should only see each one move whenever I type in its command. So let's go give it a try. It's running. That one is running. And that one is running now. Alright, and that was them running in local mode. So now I'm going to be running the local tests. I'm running the non-updated version, and I have kept on the object editor to make the UI because when I don't, for some reason it breaks. So let's get this started. Okay, so as you can see from the test, I'm passing all of them except for the 2 ratio tests, which, as we discussed in class, basically require you to implement stuff that isn't required in the assignment. Namely, that is parsing a string that has a hashtag in front of it to either set all the clients in a server to atomic or non-atomic. So I didn't implement that, so that's why the tests are failing. So besides that, as you can see, I'm passing all my other tests. I am getting some issues in the console. Basically, it's just throwing some timeout errors. I haven't really messed with changing that because it doesn't seem to affect me passing the test. But that's about it for the local test.